The main thing, hallucination. Yes, LLMs can produce answers that sound correct but are factually wrong. If you're building a healthcare app or financial assistant, this is dangerous. Dear friends, the real revolution that made LLMs possible is the transformer architecture. Dear friends, as developers, we need to be clear about the two big families of model. Generative AI is not just a new library or framework you can import into your project. It represents a paradigm shift in how we build software. Why does this matter for developers? Dear friends, because when you are building applications... Happy morning, dear friends. Here's yours, Dr. Rajanta. Welcome to Demystify with Ajay. Dear friends, today marks a turning point. For years, we have written codes line by line, carefully constructing logic and system. But generative AI changes that. It's no longer just about us telling the system what to do. It's about the system creating alongside us. This is more than a tool. It's a shift in how we build, test, and deploy software. Instead of starting from a blank editor, we now start with an AI collaborator. Instead of spending hours on repetitive tasks, we can focus on design, problem solving, and innovations. Dear friends, in this session, we will see how generative AI reshapes the developer's toolkit. From models like transformers and GANs to tools like GPT APIs and stable diffusion, and most importantly, we will explore what this means for us. That is how we can harness it responsibly, securely, and creatively. So get ready. Today we begin the journey from coder to co-creator. Okay, let's start with an introduction and break this down from a developer's lens. Dear friends, artificial intelligence at its core is the simulation of human intelligence. Machine learning, of course, made this real by giving us models that can learn from the examples. And deep learning, yes, with its neural network, gave us the horsepower to solve problems that were previously impossible, like real-time translation, face recognition, and voice assistant. Now, generative AI takes us into a new space. Instead of only analyzing data, it creates new data that didn't exist before. Imagine a model writing unit test for your code base, a tool generating UI mockups from a text prompt, or a system simulating network traffic for testing without exposing sensitive data. As a developer, this means we are moving into a world where we don't just write code. We engineer workflows around AI models. So we need to think in terms of APIs, pipelines, optimization, and deployment. And that's what makes this so exciting. Generative AI is not just research anymore. It's a practical tool for developers like us. Before we get into the architecture that powers generative AI, we need a foundation. Yes, the three main types of machine learning. First, supervised learning. Dear friends, think of it like pair programming with answers provided. So you show the model an input and its correct output, and it learns the mapping. For an example, training a classifier that detects whether a log entry is an error or a warning. So developers use this when datasets are labeled and structured. Unsupervised learning. So no labels here. So the system must find patterns in the raw data. For us, that could mean clustering logs into categories, segmenting customers without predefined labels, or compressing data for efficient storage. Next, reinforcement learning. So this is about trial and error with feedback. So think of an agent in a game. It takes actions, gets rewarded or penalized, and improves over time. So developers see this in robotic or recommendation system, and more recently in aligning large language model through reinforcement learning with human feedback. Why does this matter for developers? Dear friends, because when you are building applications with generative AI, you will often mix and match. You might use supervised learning for classification, unsupervised learning for clustering, and reinforcement learning for fine-tuning behavior. Knowing these paradigms Let's you design the right solution for the right problem. Now, let's talk about the real engine driving generative AI. Yes, large language model or LLMs. So these are massive neural networks trained on internet scale datasets of text and code. So think billions or even trillion of parameters, essentially billions of tiny knobs that adjust during training to capture the structure of language. For developers, this is where things get exciting. LLMs are not just academic toys, they are APIs you can plug into your apps today. So with OpenAI, Anthropic, Cohere or open sourcing Hugging Face models, you can build chatbots that actually understand context. Auto-generate boilerplate code, unit tests or SQL queries. Summarize long documents or knowledge bases. Prototype apps in hours instead of weeks. And here the kicker, you don't need to train them from scratch. Yeah, you can fine tune or prompt them for your specific use case. So that means any developer can integrate advanced natural language processing into their stack with just a few lines of code. LLMs are essentially pre-built superpowers waiting for us to tap into. Dear friends, as developers, we need to be clear about the two big families of model, discriminative and generative. So discriminative model answers the question, what is this? They classify. They are used in spam detection, sentimental analysis, fraud detection. So they draw boundaries between categories. Generative model answers, what could this be? So they learn the data distribution and generate new samples that look real. For us, that means generating synthetic log data, creating product mockups, or even producing code snippets on demand. So in practice, you will often combine both. For an example, in a customer support board, a discriminative model could classify the intent of the query. A generative model could then craft a natural response. So here what the developer takeaways? Yes, discriminative models filter, generative models create, and together they gives us powerful pipelines. Dear friends, the real revolution that made LLMs possible is the transformer architecture. Before transformers, models like RNNs or LSTMs struggled with long text. They could only keep track of nearby words and quickly lost context. Transformers introduced self-attentions, a mechanism that allows the model to look at all words in a sequence and figure out which one matter most. So for developer, this is huge. It means your chatbot can remember the flow of a multi-turn conversation. So your summarization app can condense a 50-page report while maintaining coherence. Your code assistant can track variables across entire files. And the best part, you don't need to implement transformers from scratch. So libraries like Hugging Face gives you access to pre-trained transformer models. Your job as a developer is to fine-tune them, optimize them for your use case, and deploy them efficiently. So transformers are not just an algorithm, they are the backbone of modern AI development. Difference while transformers dominate text, generative adversarial networks remain a critical tool for image and media. And here's how GANs work. One model, the generator, creates data. So the other, the discriminator, critiques it. Through this back and forth, the generator gets better until it produces output. So realistic, they can fool humans. And here for developers, GANs are practical in synthetic data sets. So if you don't have enough training data, GANs can create it. Next, game, develop and design. Yes, generating texture, phases and environments. And in media enhancement, it upscaling images, coloring videos or removing noises. Different GANs can be tricky to train from scratch, but pre-trained GANs are widely available. So the developer's role is to integrate, fine-tune and build pipelines where GAN outputs provide real value. And dear friends, this is where theory meets practice. Yes, as developer, we don't need to reinvent the wheel. The tools are here. Yes, OpenAI's GPT, API for natural language task. Stable diffusion, yes, for text to image generation. LangChain for building RAG system and AI pipelines. Vector database like Pinecone or Wave to handle semantic search. Our role is to stitch these tools together into real world apps. It's less about training giant model and more about engineering end-to-end system. So handling input, integrating APIs, managing context and deploying to production. Difference as developers, large language models open up practical opportunities across multiple domains. I just let you know one by one. The first one, software development. LLMs can generate boilerplate code such as bug fixes or even write unit tests. Tools like GitHub Copilot already do this, but you can also build your own lightweight assistants tuned to your code base. Next, enterprise knowledge system. With RAG, that is retrieval augmented generation, you can connect LLMs to a company's private database. So imagine an AI that answers HR questions, generate compliance reports or surface insights from thousands of documents. Next, customer support. Difference, instead of rigid chatbots, you can deploy conversational agents that actually understand context and tone. So these can escalate tickets automatically or draft human-like response. Next, content automation. So LLMs can draft blogs, create marketing copy, or even generate personalized email at scale. Difference, the developer's edge or yes, LLMs are like Lego box. You don't just use them as is. You wire them into APIs, microservices, and workflows. That's how you build applications that solve real problem instead of just being AI demos. Difference, generative AI is not just about fancy text and images. As developers, there are so many things is there. Yes, let I just specify where you can apply it. Yes, healthcare. AI can generate synthetic patient record to train models while preserving privacy. Developers working in medtech can use this to test system without exposing real data. Next, entertainment and gaming. So procedural generation is now supercharged. NPC dialogue can be dynamic, music can be AI generated, and assets can be created on demand. Imagine building a game where every playthrough feels fresh because AI generates unique content. Next, design and architect. Tools that turn natural language processing into UI wireframes or architectural sketches into full 3D renders. Next, business productivity. Difference, meeting assistants that generates action items or project management tools that draft reports or AI co-pilots for analysts that summarize dashboards. So for developers, this means new market to build in. We are not just using AI, we are packaging it into apps, platforms and cloud service that organization can adopt. Now, dear friends, now we need to be clearly eyed about limitation. Yes, from a developer perspective, these are not minor issues. They shape how we design our system. The main thing, hallucination. Yes, LLMs can produce answers that sound correct but are factually wrong. If you're building a healthcare app or financial assistant, this is dangerous. Developers must add guardrails, validation layers, fast checking, pipelines, or hybrid architecture that combine LLMs with deterministic logic. Next, bias. Since models learn from internet scale data, they inherit into biases. As developers, we must monitor for fairnesses and implement bias mitigation strategy. Next, cost and compute. Yes, dear friends, running large models is expensive. Deployment requires optimization techniques like quantization, pruning, or distillation. Sometimes the right solution is not a massive LLM, but a smaller fine-tuned one. So lack of reasoning. Yes, these models don't truly understand. They predict patterns. For complex reasoning, we need external tools like symbolic logic or retrieval system. And here, as a developer, we can't blindly trust generative AI. We must design fail-safes, fallbacks, and monitoring system that makes these models production ready. Different security is one of the most important areas where developers need to be vigilant. Generative AI introduce new attack surfaces as like deepfakes. Yes, gangs can generate realistic audio or video. As developers, we need a detection system and authentication protocol to counter these risks. Next, prompt injection. Yes, an attacker could manipulate an LLM powered app by crafting malicious inputs. So imagine your chatbot being tricked into revealing sensitive data. Next, AI generated code vulnerabilities. If you deploy code directly from an LLM without review, you risk security flaws. So always enforce code reviews and static analysis. Next, data leakage. Yes, dear friends, if an LLM was trained on private or copyrighted data, outputs might leak sensitive information. So developer must sanitize outputs and control training data sources. So for us, security is not an afterthought. It's a design principle. As we integrate generative AI into apps, we need to think like adversaries and build secure by design architecture. Dear friends, ethics in AI may sound abstract, but for developers, it translates into real design decision. Yes, if AI generates a code snippet or an image, who owns it? The user, the developer, or a model creator? As developer, we need to think about licensing and IP rights. Next, transparency. Users should know when they are interacting with AI generated content. Adding disclaimers or watermarks is part of ethical design. Next, bias and fairness. Yes, dear friends, we must actively monitor whether our system discriminates even unintentionally. So this could be as simple as testing output across diverse scenarios. And misuse preventions. Yes, could our system be used to spread misinformation or generate harmful content or automate attacks? Yes, developers have to anticipate misuse cases and set boundaries. In other words, ethics is not just philosophy. It's part of our job. Every design choice we make either increases trust or erodes it. So dear friends, here where we close the day one. And here's the message I want to every developer to carry forward. Yes, generative AI is not just a new library or framework you can import into your project. It represents a paradigm shift in how we build software. For decades, our job has been to write explicit logic, that is, if this, then that. But generative AI breaks that mold. Instead of coding every detail, we are now integrating systems that can generate, adapt, and collaborate with us. So the opportunities are massive. We can automate tedious workflows, accelerate prototyping, and even create entire applications that we are unthinkable before. But with that power comes responsibility. Yes, these systems can hallucinate, introduce bias, and open new security risks. And that's exactly where developers matter most. Our role is not being replaced. On the contrary, it's being elevated. We are not just coder anymore. We are architect of AI powered system. We are the one who make AI safe, reliable, and truly useful. This series will guide you through that journey. So from concept to hands-on coding, from tools to deployment-based practices. So the future is not AI replacing developers. The future is developers who know how to build with AI leading the way. And that's exactly what we are preparing for starting today. So the detailed content of this generative AI series is pinned in the first comment. So check it out to follow along day by day. If you found this today's session useful, so don't forget to like, share and subscribe to stay tuned for the next episode in generative AI series. Happy learning, dear friends.